Ever wondered how those massive machines called airplanes defy gravity and take to the skies? It's all about the fascinating world of aircraft characteristics and mechanics. Understanding these principles isn't just for pilots and engineers. If you're captivated by the magic of flight, knowing these details just makes the experience even richer. In the next few minutes, we'll unravel the fascinating world of airplanes and their mechanics. So, buckle up for this flight of knowledge. To start off, let's dive into the different types of aircraft and the mechanics that allow them to fly. An aircraft in its most basic definition is a vehicle capable of flight, defying gravity and soaring through the skies. But how does this happen? It all comes down to the principles of lift. There are two main types of lift, static and dynamic, that enable these machines to take to the skies. Static lift is the principle behind lighter-than-air aircraft, such as hot air balloons and airships. These aircraft rise and fall by adjusting the temperature or the volume of the gas inside them, thus altering their buoyancy. On the other hand, dynamic lift is the key to heavier-than-air aircraft like airplanes, helicopters, and gliders. These aircraft generate lift by moving through the air. Wings or airfoils are critical in this process. As an aircraft moves forward, air flows faster over the curved top surface of the wing than the bottom, creating lower pressure above and higher pressure beneath, which lifts the aircraft into the air. Airplanes, the most common type of aircraft, rely heavily on dynamic lift. Their wings, combined with the power of their engines, allow them to reach impressive speeds and altitudes. Helicopters, while also using dynamic lift, have a unique twist. Their rotating blades act as wings, providing lift as they spin. Gliders, on the other hand, are a marvel of efficiency. Devoid of engines, they rely on air currents and the manipulation of their wings and control surfaces to glide through the sky. Hot air balloons, the epitome of static lift, rise by heating the air inside the balloon, making it less dense than the surrounding air. As you can see, the world of aviation is diverse, with each aircraft type having its unique mechanics. From the simple elegance of a hot air balloon to the complex dynamics of a helicopter, each aircraft is a testament to human ingenuity and the dream of flight. Now that we've understood the different types of aircraft, let's break down the components of an airplane. In every airplane, there are four main components: the wing system, tail surfaces, movable surfaces, and the power plant. Each of these contributes to the magic of flight in their unique way. Let's start with the wing system. The wings are the heart of an airplane. They are designed to create lift by changing the direction and pressure of the air that passes over them. This lift is what keeps the airplane aloft, defying gravity. The wings also house the fuel tanks and landing gear in most aircraft. Next up, we have the tail surfaces. These include the horizontal and vertical stabilizers. The tail surfaces provide stability and control, keeping the airplane level and on course. Think of them as the rudder of a ship, guiding the airplane through the skies. Then we have the movable surfaces. These are parts of the wings and tail that can change shape or position. They include the ailerons on the wings for rolling the plane, the elevators on the tail for pitching the nose up or down, and the rudder on the vertical stabilizer for yawing the nose left or right. These surfaces allow the pilot to control the airplane's attitude and direction, making it possible to steer the aircraft safely. Finally, we have the power plant. This is where the thrust comes from. It includes the engines, propellers, or jet turbines that push the airplane forward. The power plant is the muscle of the airplane, providing the force necessary to overcome drag and maintain speed. So, there you have it, the wing system, tail surfaces, movable surfaces, and power plant. These components work together to ensure a safe and smooth flight, each playing its vital role. But remember, each type of aircraft may have these components arranged or designed differently to suit its specific purpose and performance requirements. These components work together to ensure a safe and smooth flight, each playing its vital role. Beyond the aircraft itself, there's a whole world of planning that goes into maintaining these machines and ensuring they can operate safely from airports. One might wonder, what exactly does this planning involve? Well, let's dive right into it. Firstly, the general dimensions of an aircraft play a pivotal role in both airport and maintenance planning. These dimensions include the aircraft's size, turning radius, circling radius, speed, weight, and wheel configuration. All these factors are meticulously considered to ensure smooth operations. For instance, the turning radius of an aircraft impacts how it maneuvers on the ground, while its weight influences the type of runway it can use. Then we have factors such as jet blast, fuel spillage, and noise. These may seem less glamorous but are equally important. The jet blast from an aircraft can be dangerous if not properly managed. Fuel spills, while rare, need to be accounted for in safety protocols. And noise, a key concern for airports near residential areas, can dictate flight paths and operating hours. But how do airport planners get all this information? Here's where reference documents come into play. Aircraft manufacturers provide detailed technical data and dimensions for different models through publications. One such example is the Aircraft Characteristics Publications, or ACPs, offered by Airbus. These documents cover a range of aircraft from the A220 to the colossal A380, providing invaluable data for airport planning and maintenance. In essence, every aircraft is a unique blend of engineering and design, each with its own set of characteristics. Knowing these details is not just for the engineers and pilots. Whether you're an air traffic controller, a ground crew member, or even a passenger, understanding these characteristics can provide a new appreciation for the intricate ballet that is modern aviation. So, the next time you see a plane gracefully taking off or landing, remember there's a wealth of planning and preparation behind that simple act. Understanding these characteristics is essential to ensure safe and efficient operations at airports. We've covered quite a bit of ground, or should I say air, today. We've taken a journey through the intricate world of aviation, exploring the various types of aircraft and the scientific principles that allow them to defy gravity. We've seen how static lift can buoy up a hot air balloon, while dynamic lift, generated by airfoils such as wings, keeps airplanes aloft. And let's not forget those aircraft that rely on the direct downward thrust from their engines. We've also dissected the anatomy of an airplane, delving into the importance of each component, from the wing system that sustains the aircraft in flight to the tail surfaces that stabilize the wings and the movable surfaces that control the plane's attitude during flight. And of course, the power plant at the heart of the aircraft, providing the necessary thrust to propel it through the air. And finally, we've looked at airport and maintenance planning, understanding the need for accurate information on the aircraft's size, turning radius, circling radius, speed, weight, wheel configuration, jet blast, fuel spillage, and noise. We've seen how reference documents like Airbus's aircraft characteristics publications provide these essential details. Remember, each aircraft is unique, and understanding its characteristics is key to the art of flight. Whether you're a pilot, an engineer, or simply an aviation enthusiast, this knowledge is invaluable. Before we wrap up, I'd like to remind you to subscribe and hit the bell icon for more fascinating insights into the world of aviation. Don't forget to shower your appreciation with a thumbs up if you enjoyed the journey. Sharing is caring, so pass along this flight of knowledge to your friends and fellow aviation enthusiasts. Remember, pressing the bell icon will keep you updated with our latest content. Thank you for joining us on this flight of knowledge. Until next time, keep your curiosity soaring.